Happy is on. Cristiano is on. Or which Cristiano is this? Manu. Okay, we continue. Okay. Interquartile range. Interquartile range. The interquartile range measures the dispersion in the middle, that is 50% observation of the distribution. The interquartile range is defined as the difference between the upper quartile and the lower quartile of the data. It's got by using the formula IQ3 is equal to Q3 minus Q1. Q3 minus Q1. So you'll get the upper quartile minus the lower quartile. So the interquartile range is the upper quartile range minus the lower quartile range. Computation of the interquartile range for any given distribution, we must compute its lower and upper quartiles if they have not been given. So we have an example there. We have an example there. Are we there? The table below shows the number of participants in a certain workshop in Colin Hotel, Mukono. So number is always, the number of participants is always discrete. And we said for discrete, we always use inclusive. For discrete, we always use inclusive. So we have from 20 to 24 up to 50 to 54. Then we have the frequency from 11 up to 1, up to 1, up to 1. Are we there? So the first thing that you're going to do, let me just get the frequency here. Let me just copy the frequency. All that we need is the frequency. All that we need is the frequency. Let me paste it there. Let me just enlarge this. Let me enlarge this and make them 20. Oh, make them 16. Good. We don't need this column. We don't need this column. We don't need this column. We can just delete the column. Good. So we begin, get me the less than frequency. Get me the less than frequency. What should I type in the first class? Less than cumulative frequency. What should I type in the first class? Hey, don't sleep. Give me the value. Hey, Elizabeth, Elizabeth saying 11, Members, don't sleep. 11. Good. Next value. Sereko, you're right. Next value. 35. I hope we all know how to get this value. Next value. Chris is saying 65. Tasha, you're right. Hey. Next value. Albert is saying 83. Albert is saying 83. Next value. 94. 94. Next value. 99. 99. And lastly, 100. 100. Good. So that is all that we need. After we've gotten this, remember we've done this in the previous lectures. So after we've gotten the cumulative frequency, the first thing that we're going to do is to find the position. And that position is gotten by, since the position of the upper quartile, that is Q1. Q1, you'll get N, which is 100. You divide it by 4. 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 n, which is 100, you divide it by 4. So what is q over 4 equal to? Q over 4 is equal to what? Same as 100 divided by 4. Q over 4 is the same as what? Elizabeth is saying 25. 25. Are we okay? Are we okay? Good. Is the speed okay? Let me know if the speed is okay. We have to move slow but sure. Is the speed okay? I'm waiting for the charts. Good. So you look for where 25 is. You look for where 25 is. You look for where 25 is. It is not here in this class. It is definitely in this class. So you highlight that class. Highlight that class. That is where our upper quartile lies, between 25 to 29. Between 25 to 29. So from that class, what is our L? From that class, what is our L equal to? What is our low? What is our lower class boundary? That class. We plug in the value. What is the lower? 24.5. 24.5. So you have 24.5. 24.5. What is the cumulative before? 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 I can see Elizabeth and Chris contributing. 11 is correct. Cumulative class before is 11. This is the cumulative class before. Cumulative class before is 11. What is the frequency of the class? What is the frequency of the class? What is the frequency of the class? The frequency of the class is 24. Good. The frequency of the class is 24. Good. And what is the class interval? What is the class interval or class width? C equal to? C is equal to what? C is equal to what? C is equal to 5. C is equal to 5. So we have 11, we have 24, we have 5. So we put that into the formula. We put that into the formula. Our L is equal to 24.5. And so our N over 4, our N over 4 was 25 minus cumulative frequency before, which is 11, divide that by the frequency of the class, which is 24, you multiply that by 5. You multiply that by 5. So do the needful and get me Q1. Do the needful and get me Q1. Do the needful and get me Q1. Chris is saying 27.4167. Need other answers? Hey, other members, contribute your answers. Contribute your answers. I only have Chris's answer, which is 27.4167. Mubarak, over rounding off Mubaraka. So it is 27.4167. 0.4167. Good. We continue. We get you at least work with 2 decimal places, 2 or 3 decimal places to be safe. 27.1. Even if you round up, you cannot get 25. When you round off that 1, you just get 27.4. So we get Q3. We get Q3. We get Q3. Again, Q3, we follow the same thing. Q3, we follow the same thing. This was Q1. Q1 was equal to 25. That was the position. Now for Q3, this is the 3rd quartile. So we shall have 3 times 100 over 4. So it is 3 quarters. It is 3 quarters. The first one is the first quarter, and the second quarter is the median, and the third quarter is 3 over 4. So we shall have 3 over 4, 3 times 100, where 100 is n. So what is the position of Q3? What is the position of Q3? What is the position of Q3? Position of Q3 is 75. Position of Q3 is 75. So I can put here that Q3, and the position of Q3 is 75. So we go back and look for where 75 falls. It is not here in 11. It is not in 35. It is not in 65. Rather, it is in this class. So this is our class, and let me highlight it with another color. Let me highlight it with another color. That is our class. That is our Q3. So from there, get me the lower class boundary of that class. Lower class boundary of that class. Lower class boundary of that class. Elizabeth, you're right. Chris, you're okay. Tasha, you're fine. Seems today people had good lunch because I can see the responses are good. Give me the cumulative frequency before. Cumulative frequency before. Cumulative frequency before. 65. 5. Good. 65. Give me the frequency of the class. Frequency of the class 18, 18, 18. And C is the same. C is the same. C is the same, which is 5. So we put our values. We compute our values. So we shall have 34.5. We shall have 75 minus 65 over 18. Then that is multiplied by 5. That is multiplied by 5. That is multiplied by 5. So quickly get me the value. Get me the value. So we have, this is 34.5. Frequency is 18. Cumulative before is 65. Then C is 5. Elizabeth is saying we have 37.278. 278. Let us work with 3 decimal places. 37.278. That is 7.278. So that is how we get. That is how we get the quartile. So we can say that Q1. What was our value for Q1? Put So to get the interquartile range, we shall have, to get the interquartile range, we shall have Q3 minus Q1. So we shall have 37.278 minus our Q1. Our Q1 was 27 point something. Our Q1 was 27.417. 27.417. 27.417. So, what do we have as our answer? When we subtract, we'll have 9.861. 9.861. 9.861 as our interquartile range. But we are interested in the interquartile deviation, and that is gotten by dividing by 2. That is gotten by dividing the interquartile range by 2. So you'll have 4.93. We'll have 4.93, and we shall see how we can make conclusions with that value. We are going to see how we can make conclusions with that value. Is anyone lost? Do we have anyone who's lost, especially those who joined from the beginning? If you just joined, semiquartile, they refer to Q2. Semiquartile is the median. Semiquartile is the median because we have the upper, median, and then the lower. So semiquartile is the same as the median. This is called the interquartile range. But if they add semiquartile range, maybe they mean the same thing, but let us deal with interquartile range. So the only way we can make a conclusion is when we get the mean. Remember, we're seeing how this value is spread from the central value. So quickly get for me the mean using that table. Using that table, f of x. So what is the first value equal to? What is the first value equal to? What is 11 times 22? We have 242. 242. Next value. For us to make a conclusion, we need to get the mean. Next value. We have 648. 648. Next value. 960. Next value. 666. Next value. 462. Next value. 235. Next value. 52. Add up everything in that column. Add up everything in that column. So you have the total is 3265. 3265. So when you divide by 100, which is the frequency, you get the mean as 32.65. 32.65. And this is how we interpret. This is how we interpret that the mean spreads plus or minus 4.93. The mean spreads plus or minus 4.93. 4.93. And the standard deviation is, and this range is not very big, so we could say it is almost heterogeneous. Although when we're giving you such, we look at benchmarks, so we shall always give you benchmarks, and you'll be in position to say which data is more heterogeneous or homogeneous, as we are going to look at an example down there. So the mean spreads 32, and the mean spreads plus or minus 4.93. Good. Any questions? That is what we call the interquartile range. That is what we call the interquartile range.
Where has the 4.93 come from?
Doctor, tell us the interpretation.
So we continue. The mean absolute deviation, which is bad. The mean absolute deviation. The mean absolute deviation. Good. Yeah, is the quartile deviation. 4.93 is the quartile deviation, which is gotten by dividing to the interquartile range. So that we get 4.93, and that's the value that we're interested in. Mean absolute deviation. MAD. The mean absolute deviation is defined as the arithmetic mean of all the absolute deviations of the values of the distribution from an appropriate average of the distribution. The absolute deviations are those differences without regards to sign. This is very important. So we don't have any negatives. That is what that statement means, and we shall see. That is why I'm highlighting it, without regards to sign. That is, all the differences are made positive. All the differences are made positive. Let me also highlight that because we shall need it. The absolute deviations are usually taken from the three common averages, that is the mean, median, and the mode. Mean absolute deviation is also known as, simply the ambulances are made positive. An example, the mean absolute deviation of a simple frequency distribution, the table below. So the table below shows length in a certain province. Emmanuel, is the network okay? So we have the length from 62 up to 121. It is tipsy. How about now? Is it still tipsy, Albert? Is the network okay? I need feedback so that I can continue. Okay, the number of failures from 3 up to 25. 3 up to 25. So the data has been presented in that table. The data has been presented in that table. So the first thing we're going to do is to get the mean. And the mean is gotten by multiplying f by x, So quickly get me the product. What is the first product equal to? What is the first product equal to? First product. Chris, you're right, 186. Chris, you are right, 186. Next product. Lena, mute. Next product is 268. Good. Next product. $560. Doreen, you're correct. Nisima, Doreen, you're correct. Chris, you're correct. Elizabeth, you're correct. Next product. 178. Brilliant. Brilliant. Next product. 500. Brilliant. Nisima, you're correct. Next product. Hillary. We've already left the 178. 3115. 3115. One to one, you're correct, Chris. Add up everything in that column. 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 Rachel, you're correct. Chris, you're correct. Hey, Rachel, that answer is not correct. Check it. Elizabeth, you're correct. So let me share with you my values and divide that by 28. Let me first share with you my values. So the values are those are the values. When I add, I will get 2128. Let me increase on the font. Let me increase on the font to 18. Good. So now these signs here, let us first get the mean. Let us first get the mean. 2128 divided by 25, because the frequency is 25. First get the mean.
So how did you get X1? Network was disturbing me. I never saw.
So the mean is 85.12. 85.12. Now, what absolute means? What absolute means is whatever we get, whatever difference we get, we shall make it positive. For example, what do we get when we subtract 62, which is x, minus x bar, which we've gotten 85.12. 85.12. What do we get? What do we get? So we get negative. We're supposed to be getting negative, but because we're making everything positive, so we shall have 23.12. Elizabeth, you're correct, but since it is absolute, we make it positive to have 23.12. 23.12. It is not a negative. The word absolute means, that is why we have the statement that I highlighted, that absolute deviations are those differences without regards to sign. That is, all the differences are made positive. All the differences are made positive. So you get me the next value. Get me the next value. Get me the next value. Virungi is saying 18.12. Going once. Going once, going twice, Chris. Another person. So Elizabeth, 18.12 solved. Next value. Next value. 15 going once, 5.2 going 2, 5.12. Next value. Chris is saying 3.8 going once, so they were going twice. So 3.88 solved. Next value. Chris, 14.88, 14.88. 14.88, 14.88. Encircle 19.88, ratio 19.88, 19.88, so 19.88. Next value. $35.88. So we multiply, Virunji, thank you. We multiply 23.12 by the frequency, which is 3. We multiply. So shall have 69.36. 69.36. Virunji going once. I was sleeping. $72.48. I can only see 69.36. 72.48. 72.48. We have what? 35.84. 35.84 going once. 35.84. 35.84. 7.6. 7.76. 7.76. Lane, that is correct. 74.4, 74.4, 74.4. So that is correct. 59.64, 59.64. And last value, 35.88, 35.88. So add up everything in that last column, add up everything in the last column. Add up everything in the last column, this column. Birungi is saying 335. So 335.36. 335.36. So we divide that by the frequency. We divide that by the frequency. So we shall have 355.36 divided by 25. 14.2144. So we can say that 85.12 plus or minus 14.2144. That's a final answer. It's enough. Where are you getting 99.334? So you'll test yourself. Do you need another example for mean absolute deviation? You know, I know you're getting the plus or minus. No, you just leave it like that. That's how we contribute. Yeah, what you're doing is confidence intervals, and that we shall deal with it later. Plus or minus. Do you need another example, Angela? Well, it's you who's going to do it. We're subtract that's the spread. That is the spread, eh? Yeah. For example, this answer where you have where you've gotten, it shows that if you have I could just insert some diagrams here. So you can see that diagram. It is plus or minus. That is what we call the spread, and this is the central value. So this is how they spread. Plus 14.2. Teddy. They applied when you want to find the mean. For example, the first example that I gave you, yeah, when you're supposed to calculate the average of the, when you're supposed to calculate the average of incomes, yeah, you might find that, say, in city council, you have people like the Lord Mayor who are earning 500, 50 million. Okay. Then you have the workers who earn as low as 100,000. So when you calculate the average, yeah, when you calculate the average, you might find that the average income, the average income of, let me first remove these things, delete. The average income of, people who work in KCCA will be, let me first answer questions, maybe like, say, 5 million. Now, these figures may have been inflated because of one person, yeah, because of this extreme value. So when we have the range will give you, yeah, that indeed, instead of saying giving one value that the mean is 85, we say that the mean lies between that range, plus or minus. So they help you to show whether the data is uniform or non-uniform. Good. They specify the exam mean or, yeah, we specify. So you'll test yourself. Somebody wanted to do another example, you can do that one. We find the mean absolute deviation. The table below shows the weights in tons of containers loaded on a ship at a certain point. Remember, weights are always in kilograms, and the data is continuous. So we need exclusive. So that's why you have 10 to 12, 12 to 14, 14 to 16, 16 to 18, 18 to 20, up to that. So first get the mean. Calculate and get the mean. Calculate and get the mean. Or you'll try this on your own time. Because I've given you the answers. You'll try it out. Good. Let us go to the last two. Or you need a commercial break of 5 minutes. You tell me commercial break, 5 minutes, or we just continue.
5 minutes commercial break.
Yes, break. Yes, what? You put break or continue? You think you're saying break, commercial break. Okay. I'm giving you a break of 5 minutes.
Yeah, I see. Break the word.
Okay, we are back. We are back. So we'll look at the last two measures of central tendency, which is variance and standard deviation and the coefficient of determination. Coefficient of determination. The variance and standard deviations are the absolute measures of dispersion. The variance of a distribution is defined as the arithmetic mean of the squared deviations of its values from the arithmetic mean. So the variance is more of like mean absolute deviation, although for it, the signs are considered. The signs are considered. If it is negative, the deviation will be negative as well, will be negative as well. So the variance is computed for both samples and population. Remember, we and we define what the population is, what the population is squared. When you're dealing with the population, the frequency, you do not subtract 1. You do not subtract 1. You do not subtract 1. And when you're dealing with the sample, you subtract 1. You subtract 1. That is where the only difference. So when it is a sample, you subtract 1. And if it's not a sample, you do not subtract 1. You do not subtract 1. So we have an example there. The table below shows the amount of calories found in 50 cookies baked for a student's party. So these are the cookies, and that is the frequency. So we definitely know we're dealing with the population because there's no word sample. There's no word sample anywhere. If you don't see the word sample anywhere, so you always assume that that is a population. That is a population. So the first thing that you're going to do is to get the mean, and we're going to populate the products first. We are going to populate the products first. We're going to populate the products first. So you get me the first product. Get me the first product. Get me the first product. Get me the second product. Virunji, that is correct. Second product going once. Third product, Virunji, that is correct. Rachel, that is correct. Virunji, you're on track. Rachel, you're on track. Oh, we only have 2 people. Virunji, you're on track. Rachel, you're on track. You're on track. Rachel, you're on track. Virunji, you're on track. Nisima, you're on track for the second last. So add up everything in that column. Seven, 7, 3, 7. You're correct. And divide that total by 50. Divide that total by 50. Divide that total by 50. So let me share with you my values. Let me share with you my values. Those are the values. Let me just increase on their font. So first get the mean, which is 7, 7, 3, 7. You divide that by 50. You divide that by 50. So you'll get 1. So the mean is equal to 154.74. 154.74. So we get the deviations. This time you leave them. If it's negative, leave it. So you'll get 140 minus 154.74. 140 minus 154.74. Get me the first answer. Good. Birunji. Rachel, Birunji, Elizabeth, I need answers. Good. 14.74. Quickly, get me others, get me others. We need to finish this booklet today. Get me others, negative. Nasima, you put the negative, you put the negative. You put the negative. Chris, you put the negatives. You put, this is not absolute. Remember, there's a big difference. Good. You don't know what answers that 1.6. I don't have the 1.6. 1.26. People don't make those small errors because they will cost you. 1.26. Rachel, that answer is correct. 2.26. 2.26. Mm-hmm. 8.26 is the last value. 8.26 is the last value. 8.26 is the last value. So let me share with you my answers. Let me share with you my answers. You have that. You have that. Compare with your answers. Of course, we have those lazy ones who are just waiting for my answers, but you're risking. So you square the deviations. You square the deviations. So you'll have negative 14.74. All that is squared. All that is squared. All that is squared. Quickly. Get me the first square. First square. 217.26. That is correct. Chris, that is correct. Virungi, that is correct. Mm-hmm. 45.4, that is correct. Mm-hmm. 1.586, that is correct. Mm-hmm. Zereka, you're correct. 5.107, you're correct, Virungi. Doreen, you're correct also. Elizabeth, you're correct. Virungi, you're correct. I'm getting the last value. Seriko, you're correct. Doreen, you're correct. So those are the values. Let me share with you the values. Let me share with you my values. We have that. And let me increase on the font. We have that. Let me make them bold as well. So we multiply the frequency. So it is 6 times 217.2676. So you get me the first value. Get me the first value. Virungi, you're correct. You're correct. You are correct. You're correct. Already you're correct. Press that value is right. Rachel, that value is right. Birungi, you are correct. Afi, you're correct. Birungi, that value is correct. Solomon, you've resurrected. You're correct. Correct. Maria B. Vivian, you've resurrected. That value is correct. Hey, you know that value is correct, and that's the last value. So add up everything in that column. Add up everything in that column. Add up everything in that column. Mm-hmm. 249.6. Happy, you're correct. You are correct. So when you add up everything, let me share with you my values. Let me share with you my values, and those are my values. I add, I bold, I put 16, I center. Good. So when you divide that by 50, divide that by 50, divide that by 50. What value do you get when you divide by 50? When you divide that value by 50, what value are we getting? So Birungi, you're correct. 49.8383. So find the square root of that. Find the square root of that. Find the square root of that answer. Find the square root of that. So that is the variance, and we need to find the standard deviation. So the square root is 5.06. That is why we have our answer, that it is 154.74 plus or minus 7.06. 7.06. 7.06. That is the final answer. That is the final answer. 154 plus or minus 7.06. So you'll test yourself. You'll test yourself with that example. You will test yourself with that example. You will test yourself for that example. We want to get to that bit where we do comparison of two distributions. Comparisons of two distributions. 16.18 is what? I don't know. You'll test yourself, and the answers are down there. The answers are down there. The variance is there. The mean is there. The standard deviation is there. And the final answer for that question is that. So you work backwards. So for you to get the answer. So we do the last bit, which is the coefficient of variation that we use to compare two distributions. Standard deviation. Over there. How is the speed? How is the speed before I continue?
The speed is okay.
Don't worry. The speed is okay. We're left with only 2 handouts, and I hope to do one this week. Mwewesa Michael, you're not contributing anything. Ulimwachi Cristiano Ronaldo. No wonder you're from Man U. Yo-ho. Rachel. But you're the one who's been giving me the values. So, good. The greater the dispersion of a given data, the larger will be its value of the standard deviation. 7.06 is the standard deviation. This is the SD. This here is the SD, standard deviation. Standard deviation. Standard deviation. Afi, which day are you talking about? The days when we finish coefficient of variation. It is simple. Coefficient of variation is simple. Coefficient of variation is simple. We're not going to calculate anything new. We're just going to use our data. Catherine, is it okay? So the greater the dispersion, plus or minus. Catherine, you've just entered. That is how we state. 154 is the mean, then plus or minus the standard deviation. The standard deviation. Mercy, we have to complete this booklet. We have to complete this booklet today. So the greater the dispersion of a given data, Mercy, you should talk to your friends. You've just come in. I've been doing those things from the word go. You've just come in. You should talk to your friends. The greater the dispersion of a given data, we've only studied for 1.5 hours. It's supposed to be a 3 to 4 hour lecture. So we've just studied for 1.5 hours. Let's complete this in the next 10 minutes. Even data set, the larger will be its value of the standard deviation. This therefore implies that the standard deviation can be used to compare the dispersion of 2 or more distribution. Or I leave it, you do it on your own. Should I? Because the next time we meet, I'm looking for another booklet. You can call it a day, but I'm not coming back to this booklet. For me, it is fine. Good. However, to arrive at a meaningful conclusion, the following conditions must be satisfied. The data should be expressed in the same units. The arithmetic mean of the 2 distributions must be the same or merely the same. So for you to use standard deviations, the units have to be the same. Once these conditions have been satisfied, the smaller of the 2 standard deviation indicates that the distributions from which it belongs to has less dispersion and it is more homogeneous. So when you're dealing with 2 distributions, for example, weight and weight, they're both measured in the same units, you can use standard deviation. But if you're dealing with 2 distributions that use different units of measurements, for example, height and weight, then you cannot use standard deviation. This is what we said. On the other hand, the larger of the 2 standard deviation implies that the distributions from which it belongs is more spread out and therefore it is more heterogeneous. As we said, the larger the standard deviation, the more heterogeneous, and the smaller the standard deviation, the more homogeneous. Coefficient of variation. This is a relative measure of dispersion that shows the standard deviation expressed as a percentage of the arithmetic by formula. Just get the standard deviation, then you multiply it by 100. Now, this is better because it deals with measurements that have different units of measurements. For example, if you're to compare workers, you're comparing their heights and maybe you're comparing their weights. Height is measured in meters, weight is measured in kilograms. So you can only use the coefficient of variation. You cannot use standard deviation. Like standard deviation, we consider the magnitude of the coefficient of variation when making assertions about the dispersion of a given distribution. The greater the value of the coefficient of variation, the greater is the dispersion of the distribution and vice versa. So we just get two values, the standard deviation and the arithmetic mean, and we multiply by 100. That's all. A study of a large number of industrial workers revealed an average pulse rate of 81 point that. So the word average there indicates that we're dealing with mean. And a standard deviation of 12.2. Now that indicates that we're dealing with the standard deviation. Measurements of their height revealed. Now remember now that height is in another, it uses another measurements. It uses another units of measurements. Measurements of their heights reveal that an average of 69.9. Now this is their heights. That's the average, and 2.7, that becomes their standard deviation. That becomes their standard deviation. We can compare the dispersions of the above two features of the workers. Yeah? Because they have two different units, that is why we use V. So V is equal to standard deviation over the arithmetic mean. So what was the standard deviation of B? B, which is the first B with the pulse rate. What was the standard deviation of the pulse rate from our question? What was the standard deviation? I'm waiting for the answers. Read and get me the standard deviation. Read and get me the standard deviation. Aban, what is happening? What is the standard deviation from this question? Standard deviation, Rachel is saying 12.2. So 12.2. And what is the arithmetic mean? What is the arithmetic mean? 81.1. So what is the CV equal to? The coefficient of variation? What is the coefficient of variation? We have 15.04. 15.04. We are lost. Gordon, why are you lost? The formula is there. Standard deviation over the arithmetic mean. Gordon, you have not been contributing. I only say we are lost. Who? You say you are lost. You've not been contributing. So that is why you're lost. If you have been contributing, you'd have given me. I continue. Get me the standard deviation of the heights. The standard deviations of the heights. You don't come from nowhere and tell me you're lost when I've been teaching. 2.7. 2.7, and get me the arithmetic mean. The arithmetic mean is the same as average. It's the same as average. Same as 69 point. All those are other names. Mean, average, it means the same. It means the same. So get me V. get me V. V is 3.86, 3.86, 3.86, 3.86. So from this, you can see that this is more homogeneous. The heights are more uniform. The heights are more uniform compared to pulse rates. The height is more uniform compared to the pulse rate. It's more uniform. It is less dispersed. Yeah, all those words pass. It is more uniform because it's smaller. So 3.86 is smaller compared to 15.04. So 15.04 is more heterogeneous. It is more dispersed compared to the height. The height is less uniform. I mean, the height is more uniform and more homogeneous. So the workers' pulse rate is more varied than their heights. More varied is the same as more dispersed. The same as more dispersed. So you'll do that last example on yourself, for yourself, the one that has test yourself, where you have the table below shows the heights in centimeters and the weights in kilograms of different workers in the coffee industry. So you'll have that data and compute the standard deviation of the workers, then compare their dispersions. Compare their dispersions. So you'll do that and work out. The answers are there. You work backward. Then we can call it a day. We can call it a day.